for lesson 5, which is linear versus non-linear relationships, day 2. Just put this on full screen. Okay, so our learning target for today is I can determine if a relationship is linear or non-linear by analyzing its equation or graph. Please write the learning target. It's the same learning target as yesterday. Honestly, it's really the same lesson. We're just practicing a little bit more. So pause the video, write down the learning target, and please try the do now before I go over it. Excellent. So I hope you pause the video and try the do now on your own. It says, determine if the following are linear or non-linear. So we're just going to write linear or non-linear next to each of these 4 graphs. This is, for answer choice A, non-linear. It's non-linear because this is a curved line. It's not a straight line. B is a linear graph because it's a perfectly straight line that you could draw with a ruler. C is non-linear because it is a curved graph. D is linear because this line could be drawn with a ruler straight line. It's a perfectly straight line. That's it. So pause it if you need to take those notes. I'm going to slide up here. So just to recap what we did yesterday, this was some of the important notes that we took yesterday. We were looking at linear and nonlinear relationships. And when we have a graph, just like the do now, it's pretty straightforward to tell whether it's a straight line or not a straight line. So in a graph, if the graph is a straight line with a constant rate of change or slope, then it's a linear equation. If the graph is not a straight line and does not have a constant rate of change, then it's nonlinear. So remember, rate of change is slope. And the slope is a set of directions from one point to the next on a graph. So with a line, if you do the same pattern, let's say my pattern is up 5, right 3, that gets me from one point to the next. And then I go up 5, right 3, that gets me to the next point on the line. And I keep doing up 5, right 3 for infinity, because lines go on forever. So a constant rate of change means you follow the same pattern over and over and over again, and the line will keep going and going and going. If it is not a line, then that pattern will not stay the same. So other graphs have points on them, but there's no constant pattern to get from one point to the next on that graph. So you might go up 5, right 3 to get from one point to the next, but to get to the next point, maybe you go up 5, right 2. Then maybe you go up 5, right 1, so the pattern changes. Sorry for the announcements, but bear with me. So equations. Graphs are great, but equations tell us a little bit more information. Graphs, we cannot draw a graph that goes on forever because graph paper can only be so big. So what happens if we want to know about points that are off the graph paper? We need to use an equation. To determine if an equation is linear, ask yourself these following questions. Okay? So if the answer to all of these questions is no, then it is linear. Remember, all of these questions has to have an answer of no in order for a relationship to be linear. So the first question we ask is, does the variable have an exponent? If it's no, great, move on to the next question. Is the variable in a radical sign? Remember, a radical sign is a square root sign. Okay, so I'm just going to put this down here. This is a radical. That's what a radical looks like. And then the last question, is there a variable in the denominator or the bottom of a fraction? The answer is no to that. The answer to all 3 of these is no, then is linear. On the other hand, if the answer to any of these questions is yes, then the relationship is nonlinear. Okay, so just want to repeat this again. Please come back to this and study this. If the answer to all three of these questions is no, then the relationship is linear. If the answer to any of these questions, any one of them, doesn't have to be all of them, just one of them, if it's yes to any one of them, then it's a non-linear relationship. So let's just take a look at a few questions, and then you guys can get to work. Please pause the video and play it back or pull it back a couple of seconds if you needed to finish those notes up. Okay. Just going to zoom in a little bit. So for question number 1, we have y equals 4 over x plus 1 for our equation. And we're always going to be looking at the variables. Trying to get myself a little highlighter here.
At this time, the library and the main floor are dismissed. Teachers, please escort your scholars to the exit.
Okay. Well, the y variable doesn't have an exponent. It's not in the denominator, and it's not inside of a square root sign. But the x variable is in the denominator, so this has to be nonlinear. X is in the denominator. Okay, so that's a nonlinear. I know that if I make points using the x and the y here, those points will never line up in a straight line. Question number 2. Y equals x squared. So I take a look at the variables. Y doesn't have an exponent, but x does. X has an exponent of 2, so this is non-linear. The x variable has an exponent. Okay. Non-linear because the x variable has an exponent of 2. Okay. It doesn't matter what the exponent is, but if it has an exponent, it's nonlinear. Okay, question number 3. I want to look at the variables. This x is inside of a radical sign. We are not allowed to have variables inside of a radical sign for linear equations. So this is nonlinear because the x variable is in a radical sign. Okay. So for question number 4, again, we want to look at all the variables in the equation or the expression. And we're asking ourselves those 3 questions. Are any of the variables, do any of the variables have an exponent? No, y doesn't, and neither does x. Okay, let's go to question number 2. Are any of these 2 variables in the denominator of a fraction? Y is not, and neither is x. So we pass that. And our last question, are any of these variables inside of a radical sign? None of these are. The answer to all 3 of those questions was no, so this is a linear relationship. Okay, so now let's quickly take a look at, these are just like our do nows. Determine if the following are linear or nonlinear.
On the 200th floor is dismissed. Teachers, please escort your scholars to the exit and assist us outside with dismissal. Thank you.
Okay, so again from our do now, I know we practice these in our do now, but if the line is curved, it's nonlinear. If it's a perfectly straight line, then it's a linear relationship. So this is a curved graph, so this is nonlinear. Number 6, it's curved. The graph is curved, nonlinear. Number 7, we have a perfectly straight line that we can draw with a ruler. This is a linear relationship. And then number 8, perfectly straight line. This is a linear relationship. Okay, well, that is it for my part of the lesson. If you are not in class and you're watching this video, please complete the rest of this on your own, then come into class and check the binder to see if you have the right answers. Come to Extra Help if you have any questions. And thank you for watching this video. I hope it was helpful. Just want to point out here, not for question number 2, not all equations have x and y as variables. Okay, so here this has v as a variable and s as a variable. Remember, the variables cannot have an exponent, the variables cannot be inside of a radical, and the variables cannot be in the denominator of a fraction for linear relationships. Okay. Have a great day, guys.